Hi everyone, welcome back to my Seurat video tutorials. In today's video, I'm going to show you how to rename Seurat cell clusters and how to change colors for each cell clusters. So again, we are using the data set from integrated normal lung tissue. For this demonstration, we still use very low resolution to reduce the cluster numbers. So we can run the resolution as 0.01. Then we can use the dim plot to have a look at the cell cluster again. So let's zoom in. You can see we have 7 clusters here. So last time we used the 4 markers to identify the cell clusters. So you can see we used the EPCAM, CLDN5, collagen 1A2, PTPRC. So we can run this feature plot function again. So we can have a look at the clusters now. So you can see EPCAM labels cluster 2. So we can name cluster 2 as epithelial cells. CLDN5 labels cluster 1, so we know cluster 1 are endothelial cells, and collagen 1A2 labels cluster 4, so we can name cluster 4 as mesenchymal cells. And PTPRC is a marker for immune cells. We can clearly see cluster 0 and 3 are labeled by PTPRC, so we know cluster 0 and 3 are immune cells. So we have a cluster 5 and a cluster 6 left. We don't know what kind of cells they are. So in my last video, I introduced the find markers. So we can use the find markers function to identify the cell types for cluster 5 and cluster 6. So let's first run the find marks function for cluster 5. So we use the minimum percentage expression as 50%. So let's run this function. Okay, you can see we find the markers for cluster 5. So let's have a look at the markers for cluster 5. So you can see the top markers here, MS4A2, CPA3, and TPSAB1. So they are markers for mast cells. So we can use those markers MS4A2, CPA3, TPSAB1, and TPSB2 as examples to have a look if they label cluster 5. So let's run feature plot for these genes. You can zoom in. So you can see MS4A2 label cluster 5, the same for CPA3, TPSAB1, and TPSB2. So now we know cluster 5 are master cells, because the master cells also are immune cells. We can name together with the cluster 0 and the cluster 3 as the immune cells. Now we can use the find markers function to find the markers for cluster 6. We can run this function. So you can see we find 186 positive markers for cluster 6. So let's have a look at the markers for cluster 6. So we can reward the average log 2 FC. You can see the top for the changes marker is CCL21. So we know CCL21 is a marker for lymphatic endothelial cells in the lung tissue, and also we identified the mark genes MMR-N1, NAMT, so they are mark genes for lymphatic endothelial cells. So we know canasta 6 are lymphatic endothelial cells. Again, we can use a feature plot to see if we can label canasta 6 by CCL21, NAMT, and MMR-N1. So we can run this function. You can zoom in again. So you can see CCL21 is a specific mark for canasta 6. NAMT is expressed in canasta 6, also expressed in mesenchymal cells and other endothelial cells. MMR-N1, you can see it is expressed in lymphatic endothelial cells and also other endothelial cells. So we use the find the markers function to identify canasta 6 as lymphatic endothelial cells. So now we know canasta 0 and canasta 3 are immune cells. We also named canasta 5 as immune cells because they are master cells. We can name canasta 1 as endothelial cells. Canasta 6 are lymphatic endothelial cells. Canasta 2, we know they are epithelial cells because they express the marker EPCAM, and canasta 4 are mesenchymal cells. So now we know the cell types for each canasta, so we can rename the cell canasta now. So to rename the cell canasta, we use the function rename idents. So here is the Seurat object name, and we give each canasta a name now. So we just need to run the rename idents function. We will name each canasta with given the name. Let's run this function. So now we can use the dim plot to see if we labeled those canastas with the name we given them. So let's run dim plot. So let's zoom in. Now you can see we named canasta 2 as epithelial cells, canasta 4 as mesenchymal cells, canasta 1 as endothelial cells, and the canasta 0, 3, and 5 as immune cells, canasta 6 as lymphatic endothelial cells. So now we only have 5 types of cells here. Each cell type has its own color. For example, the blue for epithelial cells, green for endothelial cells, and purple for mesenchymal cells. So the color words were located for each cell type by the Seurat. Because we only have 5 cell types here, it is easy for Seurat to allocate the colors. Sometimes when you have not so cell types, for example, if we increase the resolution, you can increase the number of cell canastas. When you have not so cell types, you may don't like the colors that the system allocated to your cell types. So you can change the colors. So let's have a look at how to change colors for your cell canastas. So first, let's have a look at the color codes that Seurat is using. So it is the same as the HTML color codes. So we can have a look at on the website, you can see here are the color code. Also, each code has a name. So I prefer to use the name because it's very hard to remember what kind of color from the code. So you can see for the red color, there are lots of different names, and here are the pink, orange, yellow, and purple, green, and blue. So you can choose your favorite color here. Just copy the name to Seurat. So let's go back to Seurat. So to change the colors for your cell clusters, we just need to add the colors arguments in the dim plot. So you can see here, I actually put 6 colors here for the dim plot, but we only have 5 cell clusters. So Seurat only used the first 5 colors for our cell clusters. So let's run dim plot function with the colors argument. We name it as plot 1, and we can run dim plot without the color arguments. So the system will allocate the color for each cell cluster. We name it as plot 2. So now we can visualize plot 1 and plot 2 together to see we actually change the color for our cell clusters in plot 1. So we can zoom in. So you can see in plot 1, Seurat used the colors that we chose for cell clusters. So now you know how to change colors for your cell clusters. So I'm going to stop here today. So please subscribe my channel if you would like to watch my upcoming video tutorials.